Okay, so suppose this is our cycle frame, then you have this wheel, you have this, oh right, you should also have this thing, so you have this chain connecting these two. Cool. Now okay, first of all I should draw this a bit bigger, right? So I'll just put this aside for now. I'm gonna draw the whole thing first. See, the bigger, yeah, the bigger radius, we'll just call it capital R. This is the wheel's radius. Then you have this thing, which is, let's just call this small r, right? Okay. Then there's this chain, there's this thing, let's call this guy's radius as r dash. R dash. Okay, cool. Now this is the chain. Fine. Right. You also have the pedal, so I'm gonna draw it like this. It's just a stick basically, and then you have some force. So yeah, that guy was pulling it, right, with a string or something. So it's just capital F over here. Let's say that this guy's inertia I1, right, this thing, and this guy's inertia I2, right? I mean, like the whole thing, so the wheel and everything with it. And in fact, you can also include this thing, but let's just say that this thing is massless, so that the center of mass is over here, right? That way the normal forces won't induce any torque. And what normal forces? Well, this stick is connecting these two. This is probably supposed to be, the cycle frame should be connecting this to the, I mean, it should make this a rigid body. That's the cycle frame that should keep this distance constant and stuff. But we'll just say, okay, there's a stick, and yeah, that's putting the force that's keeping these things in those places. Anyway, you have the cycle frame, which we'll just think of as, and also the front wheel, I'm not thinking of that right now. I'm just thinking of what's happening with the back wheel and this pedal and stuff. The front wheel is basically like, if you had like a carriage, an external carriage, and attached to this thing. I'm just gonna draw a box around this, right? And if it was attached to this, then yeah, that's our front wheel, right? So I'm just gonna ignore that, because this has no tendency to move. It's not like doing anything. And naming variables for this guy is gonna make everything more complex. So let's just not think of that. So yeah, I mean, like for a unicycle or something, this could work, right? And I don't know if the front wheel actually matters or not. Please tell me if it does. Anyway, this is our cycle frame. It's supposed to be a cycle frame. Okay, it's a box. Whatever, let's just say that the complete cycle has mass small m, right? Let's start writing some equations. Oh, of course, you got the friction force over here, right? So friction force F like this. I think the normal force is going to push it in this direction, then friction force will rotate it about the center of mass. Let's write down some equations now. First we'll need to figure out what this, okay, actually, you know what, I'll just say that this thing, this wheel, and also this with it is rotating with alpha, and alpha will be positive if it is clockwise. Okay, so yeah, like this thing is going to go with alpha capital R, right, because this is a stationary point. Then because this rod is like moving with it, so this is also going with alpha R. Okay, cool. Right, and like the whole bicycle is going with alpha R, right? Yeah, so what we can say is that for this complete system of bicycle plus wheels and everything, you have the net force is just capital F minus small f in this direction. Well, that's equal to so this bike or whatever this thing is, well, this guy, it has its m alpha or whatever, how do I even say that, its center of mass is moving with alpha r, right? This guy's center of mass, this wheel's center of mass is moving with alpha r. So what do you do? Just like mass of this guy alpha r, mass of this guy alpha r. And the thing is, like, this rod is moving with it and the frame is moving with it, so everything has, it has m alpha r with it. So just add all of these m's up, right? You can name them, you can like say it's m1 m2, this complete thing is like capital M, whatever. Just combine all the m's, that's what's going to happen. So we just get like m alpha r, right? That's our mass times acceleration. Okay, that's the first equation. We just want the torque equations for these two guys as well, I think. Oh, also, first of all, we should figure out what's the equation for this chain, because this is supposed to be taut all the time, right? Yeah, so because these 2 points are stationary related to each other, this yeah, with respect to the reference frame of like this, these 2 points, this thing is moving with r dash alpha and this thing is moving with r alpha, and these speeds should match string constraint. So what you get is like alpha dash, okay, you know what, this thing, it's supposed to be moving with alpha dash, right? And clockwise is positive, of course. So alpha dash is equal to, oh, I just should write the equation. So you got r dash alpha dash, that's equal to r alpha. So then alpha dash is equal to r upon r dash alpha, right? We'll substitute that somewhere, right? Because we don't want alpha dash, we want alpha. We want to know um, like what alpha capital R is, because that's going to give us like the acceleration of this whole thing. And I think it should be positive, right? In that case, it's going to move in this direction. If it's negative, it's going to move in that direction, whatever. Okay, so you got this equation. Now let's do the torque equations. So for this thing and for this thing, by that I just mean, you know, like this system. Yeah, that's what I'll say. So you have the normal force because of whatever axle thing is holding it, but that doesn't matter in the end because it's right at the center of mass. So yeah, what do you have? You just have, oh, also you should probably have the tensions. So you know, like this is tension T1, this thing is tension T2, right? This part has tension T1, this part has tension T2, whatever. Let's start writing it. So clockwise is positive, then you got T1 R dash, right? Then, well, this is in this direction, so it's supposed to be negative. Got negative T2 R dash, cool. Anything else over there? I don't think there's anything else. Is there? Oh, also this is the thing. So you know, the main reason why this is moving is because this pedal without the pedal, actually just the rod that connects the pedal to it. Anyway, this is being pulled with capital F, so it creates a torque. Oh, let's actually call this length as a small l. So the torque will be negative, of course, like negative FL, I think. Yeah, it's supposed to be thing. Okay, and this is equal to, right? So like this is gonna make it, it's gonna try to move it in this direction, right? That's what the torque would do, but then it's actually moving it. Anyway, we'll see what happens. So this is equal to you know, I alpha. So what's the inertia of this guy? Just I1, and then this guy's like alpha dash. Yeah, alpha dash is it's alpha. Fine. Alpha dash is r upon r dash alpha, of course. And hopefully we won't need this anymore. I'm gonna erase that. Okay, so you got second equation. Actually, let's resize this. Fine. You have two equations now. You need another equation because you got capital F, you got small f, you got T1, T2. I think we need another T1, T2. So small f is something we don't want. We don't want this like T1, T2 stuff. Yeah. Let's write down the torque equation of this guy. Okay. So what you have? Same stuff, right? The T1, T2 stuff. Okay. This is T1 small r in this direction. That's negative, right? So negative T1 small r. I think we should first of all write down the T2 stuff. Yeah, I guess. So just T2 small r minus T1 small r, right? Any other stuff happening? Oh, that's the friction thing. So that's positive. Yeah. So like plus small f capital R. That's our torque, and that's equal to I2, and then what is the thing? Okay, alpha, right? Yeah, cool. So we want alpha, we don't want this small f anywhere, and we don't want this, oh, these T1, T2 stuff, we can actually cancel that anyway, right? So we can just say, you know, let's multiply this whole equation by r, this by r dash, and add, this will get cancelled, right? So it's got like what? You got f, this guy, and then you got r dash minus capital F L R. Yeah, it's supposed to be R. Then that's equal to, we were doing this times r dash, right? So I2 r dash alpha plus, so for this guy just like I1 r squared upon r dash alpha. Cool. What else do you not want? You don't want this small f. So small f is equal to mr alpha, wait, no, capital F minus mr alpha, right? Okay, so this will just become capital F times all of this stuff, r dash minus, you know, lr, right? And then you got the negative mr alpha. So wait, you also want the mass over there, sorry. Yeah, right. Oh no, that was with capital F in fact. Okay, cool. So r dash minus lr. Okay, then you also have the negative mr alpha, so I'm gonna put that, and that's gonna make this what? Okay, that goes toward that. It's gonna become positive. We got alpha common I2 r dash plus I1. My handwriting is really bad. R squared upon r dash plus, this is not squared, it's r dash, right? Okay, plus, so that, yeah, you got that alpha out is mr, and then another r is like mr squared r dash. Okay, let's check the dimensions first. Inertia, radius. Okay, fine. This is like length, of course. Okay, this is also good. Length. Force. Force times length is equal to alpha times inertia times length. Length times alpha is just what? Acceleration, that times of inertia. Well, that's weird. Force times length is like energy. Inertia times acceleration. That's not energy, is it? Something's going wrong, isn't it? Oh, it's not just length, it's like length squared, sorry. Okay, so force times length, right? Okay, you know what, just actually write down the units. So you got kg meter per second square, then you got like meter cube or something. Over here you got it's just per second. Okay, actually this thing's like meter per second, and then you got inertia, it's mr squared. It's like kg meter square, and then meter per second is like meter cube per second. Oh, this is also second square, right? So cool. Dimension, it's looking correct. So the conclusion is, if this thing has to be positive, then you should have r dash, and f is positive anyway, right? So yeah, you should have r dash bigger than lr. Yeah, so once again, capital R was this thing, r dash was this, small r was this thing, and small l was this, I guess. Yeah, that's it. So based on the geometry of our cycle, or whatever this thing is, yeah, you can actually figure out if it's gonna move forward or backward or whatever. Most likely my theory is wrong somewhere, so please correct that. Right, bye.